Let's look at an example with the binomial model and how GeoGebra is going to help us find those probabilities. So we have an Olympic archer, and he's able to hit the bullseye 80% of the time. We're going to assume each shot is independent, so that probability isn't changing, and he's going to shoot 6 arrows, and we want to find the probability of these different events here. So this first one asks for what's the probability his first bullseye comes on the third arrow. So this one is actually describing a specific sequence of events. And when that's happening here, if they're specific of how these successes and failures have to occur, then that's going to bring through our multiplication rule from probability. So with this, to match the wording here, he gets his first bullseye on the third arrow. What we need to see is that he misses and then misses again and then gets the bullseye on that third arrow. So he's going to make it 80% of the time. So we know the probability of making it to 80%, which means missing it, is going to be 20%. 20%. And then we just multiply those together for a 0.032. So there is a 3.2% chance his first bullseye is on the third arrow. So this scenario for this first one is not binomial, and I just want to show you the difference between if they tell you a specific sequence versus not. So not binomial here, just our multiplication rule. With this next one, we're looking for that he misses the bullseye at least once. So now what we're working with is those 6 trials, and we want to see that he misses at least once. Now I put this one in here to emphasize that importance of wording. So remember, with these Bernoulli trials, we can have success and failure. Again, it isn't necessarily how we think of success and failure in English. It's more in terms of statistics of success is what we're looking for. And in this question, we're looking for him to miss. We're looking for him to miss the bullseye at least once. So I threw this in here because it can feel wrong when we're thinking about success and failure, but probability of success in this case is him missing the bullseye. So that would be 0.2. And then our probability of failure here would be if he's making the bullseye, which would be 0.8. So just be careful with the information they give you and then how they're asking the question in terms of what designates what is the success and what is the failure. So the model I'm going to use here is a binomial model because they're not telling us a specific sequence of events. We just want to see that he misses at least once. So it can happen in any order. We have 6 trials, and our probability of success here is at 20%. And I want to see what's the probability that he misses. So X is going to represent the number of misses, is at least, so more than or equal to 1. And now this is where I'll go to Geogebra. So just to show you again how to get to the screen we want to, here's Geogebra. You'll want to go to More Apps, and we're doing probability. And when we open up probability, it's always going to go to the normal model. So we need to switch. So first go over to our drop-down menu and switch to binomial. And then before you calculate anything, you need to change your number of trials, which in this case is 6, and probability of success, which in this case is 0.2, and it'll adjust accordingly. And now we want this more than or equal to 1. So we want to shade from more than, starting at 1 and above. So this will be right-sided. So we're starting at a value and then shading everything to the right, and we want it to start at 1. So you can see from the visual here that this idea of missing at least once is that he's missing once or twice or 3 times or 4 times and above. And with that, we get a probability of 0.7379. All right, this next one is that he gets exactly 4 bullseyes. And in fact, the next of these is him making bullseyes. So this is going to switch around to wording that tends to make more sense here. But the fact that he's getting bullseyes, so there's still 6 trials, but now our probability of success is going to switch to that probability of getting a bullseye. And probability of failure would be missing, just that 0.2. So I'm going to switch over to a binomial model with 6 trials and a 0.8 probability of success. So what we want here is the probability that he makes exactly 4. So when I'm in Geogebra, I need to switch it around. So it's no longer 0.2, now it's going to be a 0.8. So now this makes more sense of him making bullseyes. We expect him to make a lot here because he has this high probability of success. And then for exactly 4, I'm going to look at this right-hand side over here because this has all my exactly values, and I just need to look up 4. So that would represent him making 4 bullseyes is a 0.2458. Part E, he gets at least 4. So again, 4 is the very least value. We want everything above that. So what's the probability of x being more than or equal to 4? So we need to switch in Geogebra to what form we're using. So at least is going to be this right-sided, so it stops and it has everything off to the right-hand side. And we need our value of 4 there for a probability of 0.9011. And I'll just make a note that this was a right-sided probability. So we use that right-sided function. For at most 4, this will be left-sided. The idea that we'll have a value that we stop at, but then we want everything less than or equal to that value. So we're going to switch the direction in Geogebra and go off to this left-sided. So left-hand side, going to 4. So that should be a 0.3446. And then this last question of how many do we expect him to get and with what standard deviation. So mean and standard deviation, you can calculate with the formulas, or if you're in Geogebra already, you can just copy them from up here in this upper left-hand corner. So mean is 4.8 and standard deviation of 0.9798. And we can make a sentence here of we expect him to get about 5 bullseyes. And on average, this will deviate by about 1 bullseye. All right, so that's how we can find our probabilities and expected value and standard deviation.